Hello students, today's topic is refractive index. So to understand refractive index, let us first understand what is optical density. Okay? So density, यहाँ density का मतलब ये नहीं जो हमने पहले पढ़ा था mass by volume. Okay? ये density है optically denser. So optical means what? Light. Light के लिए जो density है, light जो density face कर रही है. Acha, to understand that part, let me give one example. Suppose there is an area like this, similar area. Some plants are there in both the areas, equal amount of area both are, and now I'm planting some plants. Okay, suppose these are the plants. Okay. Now just check this one simply. पहला वाला केस देखो, second वाला केस देखो. If I want to move through this particular area, then in the first case, in this case, I can move faster than that of the second one, isn't it? ऐसा ही कुछ है, ऐसा ही कुछ एरिया होता है, ऐसा ही कुछ मीडियम होता है जिसके थ्रू लाइट जब ट्रैवल करती है तो उसे ये मूवमेंट में डिफ़िकल्टीज फेस करनी होती है. तो जहाँ ज़्यादा, जैसे ये वाला सेकेंड वाला पार्ट क्या है, अगर मैं इसे एक जंगल के नाम दे दूँ क्योंकि पेड़ पौधे हैं तो इसे हम बोलेंगे घना जंगल, isn't it? और ये फर्स्ट केस में इट इज़ नॉट दैट डेंसर. आई कैन मूव, प्लांट्स आर देयर बट आई कैन मूव इजीली देन दैट ऑफ द सेकेंड केस, राइट? सो लाइट के लिए भी ऐसा ही कुछ मीडियम होते हैं जहाँ पे उसे मूवमेंट करने में मुश्किल होती है और उसके वजह से क्या होता है, लाइट का जो स्पीड है वो कम हो जाती है, जिसमें जो ज़्यादा घना होता है, जो ज़्यादा डेंसर होता है. सो ये लाइट के लिए डेंसर है. सो देयर इज़ नथिंग टू डू विद द मास बाय वॉल्यूम. ओके. सो ये जो ऑप्टिकली डेंसर मीडियम होते हैं या दो टाइप के मीडियम, अगर इन दोनों को मैं कंपेयर करूँ, ये दोनों एरिया को कंपेयर करूँ, दोनों ही जगह पे घना है बट पहले से सेकंड वाला ज़्यादा घना है. ऐसे ही लाइट ट्रैवल करती है ट्रांसपेरेंट मीडियम में, राइट? ट्रांसपेरेंट मीडियम में लाइट ट्रैवल तो कर रही है, लेकिन दोनों ट्रांसपेरेंट मीडियम में से कौन सा ज़्यादा घना है, और या तो फिर हम ये कहें कि इस मीडियम में लाइट इजीली ट्रैवल नहीं कर सकती, या फिर अगेन इन आर फिजिक्स टर्म्स इफ विल से द स्पीड ऑफ लाइट इज लेस देन दैट ऑफ द अदर वन. सो ये जो सारी ऑप्टिकल डेंसिटी की बात हम कर रहे हैं, लाइट के मूवमेंट की बात कर रहे हैं, ये उस मीडियम जिसको हम रेयरर या डेंसर बोल रहे हैं, ये दोनों ही, मैंने जैसे कहा, ये दोनों ही केस में ये घना हम बोल सकते हैं, लेकिन हम बोलेंगे सेकंड वाला ज़्यादा घना है देन द फर्स्ट वन. तो ये जो फर्स्ट वाला हुआ, ये मीडियम हुआ रेयरर, ये मीडियम हुआ डेंसर. आई होप इट इज़ क्लियर. सो अब लाइट के लिए भी ऐसे ही दोनों एक जैसा मीडियम है, ट्रांसपेरेंट मीडियम है, बट पहला वाला जो केस हमने यहाँ पे जैसे एग्जांपल देखा प्लांट के लिए, उस मीडियम को हम बोलेंगे रेयरर मीडियम फॉर द लाइट टू मूव. सो स्पीड ऑफ लाइट इज फास्टर बिकॉज इसमें जैसे कम पेड़ पौधे थे और हम आसानी से मूव कर पा रहे थे. सेकंड में ये पॉसिबल नहीं हो रहा था. सेम केस होता है लाइट के साथ, लाइट के स्पीड के साथ. ओके. तो अब ये मीडियम, ये जो मीडियम है कि कौन कैसे मेजर करेंगे हम, ये जो मेजर करने का मेजर जिससे करते हैं हम, उसी को रिफ्रैक्टिव इंडेक्स बोलते हैं. आई होप इट इज़ क्लियर नाउ. और ये जो रिफ्रैक्टिव इंडेक्स है, ये दो तरीके का होता है. दो तरीके से हम इसको मेजर करने का तरीका को हम रिप्रेजेंट कर सकते हैं. एक होता है एब्सोल्यूट, दूसरा होता है रिलेटिव. ये जो टर्म्स को आप देखो, एब्सोल्यूट क्या है और रिलेटिव क्या है. एब्सोल्यूट क्या है, एक फिक्स्ड पॉइंट के साथ, एक फिक्स्ड वैल्यू के साथ हम जिसको हम कंपेयर करें, और रिलेटिव क्या है, दो डिफरेंट चीज़ों के साथ. इज दैट क्लियर? अब मैं बहुत एक कॉमन एग्जाम्पल देना चाहती हूँ एब्सोल्यूट के लिए. सपोज मान लीजिए किसी सब्जेक्ट में 80 में से 30 लाने से पासिंग मार्क्स है, तो मैं वहाँ पे बोलूँगी कोई बच्चा का अगर मैं इवैल्यूएशन करूँ और पूछूँ कि ये पास है या फेल है, मैं क्या करती हूँ, मैं उस 30 मार्क्स के हिसाब से बच्चा ने उससे ज़्यादा मार्क्स लाए या कम मार्क्स लाए, उसी को कंपेयर करती हूँ, राइट? सो उस केस में मेरा रेफरेंस पॉइंट क्या हो जाता है, वो 30 मार्क्स हो जाता है. तो ये कंपेरिजन जो है 30 मार्क्स के साथ, वट एवर इज़ द मार्क्स secured by that particular student, then I am comparing a absolute one. Okay, so similarly कोई किसी भी मीडियम का जो रिफ्रैक्टिव इंडेक्स है, ओके, किसी भी मीडियम का जो रिफ्रैक्टिव इंडेक्स है, अब हम एक फिक्स्ड वैल्यू के साथ, किसी एक फिक्स्ड पॉइंट के साथ, हम जैसे हम मार्क्स के केस में 30 मार्क्स के साथ कंपेयर करते थे, तो उसको हम बोलेंगे एब्सोल्यूट रिफ्रैक्टिव इंडेक्स. रिलेटिव रिफ्रैक्टिव इंडेक्स क्या है, जैसे अगर मैं दो बच्चों के मार्क्स के बारे में पूछूं, ये दो बच्चों का मार्क्स क्या है, तो आई एम नॉट कंपेयरिंग दोज मार्क्स विथ द एब्सोल्यूट वन. I am not asking here whether they have passed or failed. I am just asking that those two students, what are the marks they secured, right? So for there I am just relating two different things with each other. ऐसे ही रिफ्रैक्टिव इंडेक्स दो डिफरेंट मीडियम को, जहाँ जिसका एक एब्सोल्यूट वैल्यू नहीं है, उसको कंपेयर करने को हम बोलते हैं रिलेटिव रिफ्रैक्टिव इंडेक्स. ओके, आई होप इट इज क्लियर टू यू ऑल. सो लेट अस स्टार्ट. How do we define absolute refractive index? The absolute refractive index of a medium is defined as, it is the ratio, okay? It is the ratio of speed of light. अब जब मैं मार्क्स के बारे में बात कर रही थी, एक पासिंग मार्क्स था, ओके एक पासिंग मार्क्स के साथ मैं whether I was finding out whether the student have passed or failed. Similarly, is at that time I told you that 30 marks is the reference point or a fixed value or a absolute value with which I am comparing the marks of that particular child. राइट हियर एब्सोल्यूट रिफ्रैक्टिव इंडेक्स ऑफ ए मीडियम मीन्स क्या होता है, ये होता है एक रेशियो ऑफ द स्पीड ऑफ लाइट इन द वैक्यूम और स्पीड ऑफ लाइट इन द मीडियम. अब वैक्यूम के साथ ही हम कंपेयर क्यों कर रहे हैं, कोई मीडियम का अगर मुझे रिफ्रैक्टिव इंडेक्स फाइंड आउट करना है तो मैं वैक्यूम के साथ कंपेयर करूंगी और वैक्यूम का और मीडियम का एक दूसरे मीडियम का स्पीड ऑफ लाइट का रेशियो जो है दैट इज द एब्सोल्यूट रिफ्रैक्टिव इंडेक्स ऑफ दैट पर्टिकुलर मीडियम. अब रिफ्रैक्टिव इंडेक्स को हम डिनोट करते हैं स्मॉल एन से. सो हियर आई हैव जस्ट रिटन इन द in a formula kind, speed of light in vacuum divided by speed of light in medium, this one. As the speed of light in air is almost equal to the speed of light in vacuum, therefore absolute refractive index of a medium n equal to speed of light in air by speed of light in medium. So air or vacuum is marginally similar, I mean almost similar. There is very less difference between them. So whether we am comparing with a vacuum or with air, both are similar. Now ultimately we know that speed of light in air is how much, it is c, we denote it with c, and the speed of light in medium is small v. So now we can formulate it in this box. You can see n equal to c by v. और c क्या है, c का value it is 3 into 10 to the power 8 meter per second, which is fixed, which is the absolute value, okay, and that is the maximum we know. Okay, since c is greater than this, you have to remember, because question comes from this, c is always greater than v. Why? Because we know that the speed of light in air or vacuum is maximum, and that value is 3 into 10 to the power 8 meter per second. Now therefore absolute refractive index of a medium is always greater than unity. If we say that the formula is c equal to n equal to c by v, and c is maximum, this c value is maximum, okay, that is 3 into 10 to the power 8. So whatever value we will have for this medium, the speed of light I mean to say, so it will be lesser than this particular value. So whenever we will divide, because these are in ratio, whenever we will divide, that must be more than 1. Okay, so I hope it is clear. So refractive index is a pure number, it has no unit. Okay, it's just here the speed of light we had written meter per second. So what will happen, suppose this is n equal to, we had written n equal to c by b, and c value is 3 into 10 to the power 8 meter per second. Suppose some other medium is having 2 into, this medium is having 2 into 10 to the power 8 meter per second. So meter per second will be cancelled, and this value will cancel, and some after calculating you will get some value. So this particular value has no unit, you can see that, because we are comparing, the ratio is among the speed of light, so the units are similar, that will be cancelled out. Ultimately we will not find any unit for refractive index. So this is what it has been written, refractive index is a pure number, it has no unit. I hope this is clear to you all. So let us see one of the example. If I am saying that refractive index of a glass, okay, refractive index of a glass. So refractive index of a glass means I am comparing this refractive index of glass with, I mean the speed of light in glass with what, speed of light in air, because this is the absolute value and this is the speed of light in glass. So after this is the ratio of a refractive index, we know that speed of light by speed of light in that particular medium is the, what is the refractive index for that particular medium. Just now I gave you this example. So this was the speed of light in glass, 2 into 10 to the power 8. After calculating you will find 1.5. So ultimately we will say that n value of glass or refractive index of glass will be 1.5. This is a pure number, you can say this is a number we are getting, there is no unit for this. Similarly, let us discuss for refractive index of water. Simply if I have written water, I have not mentioned any other medium. That means I am comparing this. This is the absolute one, and this must be compared with the what? Air. Okay, speed of light in air. So that is what I have written in the formula, speed of light in air divided by speed of light in water. Now speed of light in water is how much? 2.25 into 10 to the power 8 meter per second. After calculating we will get 1.33. So refractive index of water is 1.33. Is that clear? So I hope you got what is absolute refractive index. Let us move on to the second type, that is relative refractive index. What I told you here, we are not going to take the reference point. We are not taking any absolute value. We have to compare two different medium other than air, okay, or vacuum. So similarly, as I told you that I'm just asking the marks of two students and I'm not comparing with the values whether they have passed or failed. I'm just simply asking that how much marks they have got. I have nothing to do with the what you say, your passing marks. If at all I'm going to ask the marks of an individual student, then obviously I am comparing with the passing and passing marks, that is your 30 marks, as I gave you the example, right? So let us move further and find out what exactly the relative refractive index. So when light passes from one medium, that is medium 1, to another medium 2, the refractive index of the medium with respect to medium 1 is written as n to 1. Like in the previous case, when we were writing n glass, means by default we were comparing this glass, this speed of light in glass, with whom? With the speed of light in air. Okay, here it is saying relativity is relative means what? I am going to compare this particular glass with some other transparent medium, not with this. So that is what it is saying. When light passes from one medium, okay, to another medium, this is the normal, to another, suppose this is medium 1, this is medium 2, the refractive index of medium 2, this has to be 2, okay, this medium 2 with respect to 1. If I am going to calculate this medium's refractive index, then what I will write? N2, then after that 1. Or this can be also written as N2 on the left hand side at the top 1. This either any of one case, either or cases you can be right. Okay, you can write this. With respect to medium 1 is written as N to 1 and it is called relative refractive index. I hope this one is clear, children. So N to 1 means what? In the next point, let us see here. Means refractive index of second medium with respect to first medium. So that means what? If I am saying that n to 1 means what? I am saying that refractive index of 2 with respect to refractive index 1. So whatever is here first number, that here you have to write in the numerator, and the other one you have to write with whom you are comparing, with whom you are relating, that has to be at the bottom. I hope this one is clear. Now if this is the refractive index this way, but refractive index is what? We are comparing actually the speed of light. So individually, if I am saying n2 is how much? Do you remember the formula? N equal to how, what? C by V. So now for n2, I can write C by V2 by, for n1, what can I write? C by V1, right? So if I'll cross multiply it, C by V2 into V1 by C. C cancel, and then I can write it will be V1 by V2. That is what I got. Okay, whenever there is a refractive index I am calculating for a medium, that has to be written first. After that, with whom I am comparing, then in this case the velocity will be just alternate one. That means what? If the second one, whatever is the medium, that velocity will be on the top, that is V1, and then the velocity of the medium for whom you are calculating the refractive index. Okay, so it will be V2. I hope this part is clear to everyone. Now N21 is what? From this particular formula we got speed of light in medium 1 by speed of light in medium 2. Similarly, if we'll find out N12, this example you see, N12 means what? Refractive index of second medium with respect to the first one. Now this has to be first medium with the second one. Okay, this has to be first medium with second one. So this particular one, this particular thing we can write. Just see, and I'm writing it again. This you have to correct, children. This N12 means refractive index of first medium. This has to be first medium. This has to be second medium. Now let us calculate this one. As I told you, N12 means what? N1 by N2. Now let us write it in the term of, in the absolute refractive index term. N1 becomes how much? N1 becomes C by V1 by C by V2. For N2 we have to write C by V2. Now just cross multiply it, V2 by V1. So what we, sorry, this one has to be, this is C. This is C. C cancelled out. So it will be V2 by V1. That is what we got. I hope it is clear to everybody. Now let us see some of the examples. These examples are very important actually. Children will concentrate on this. For example, if the refractive index of glass, if I am saying refractive index of glass with respect to air. So how I will write? NGA. Its value is given 3 by 2. Therefore, refractive index of air, if there is a value 3 by 2, then if it is just the reverse one, it is asked, N refractive index of A with respect to G, then it will be 1 by NGA, right? So now substitute the value, that is 1 by 3 by 2. Okay, 1 by 3 by 2. So which implies it will become 2 by 3. I hope this one is also clear. Similarly, let us practice one more. Similarly, refractive index of water with respect to air. Okay, so refractive index of water with respect to air, even if I am not writing air, so it is understood that it is compared with air only. Okay, so NW equal to 4 by 3. So therefore, if I am going to ask NAW, what it will be? 1 by 4 by 3. So it will become 3 by 4. Now, the next part is what it has been asked, that refractive index of glass with respect to water. Glass with respect to water. So now ultimately how we can calculate? Now this one is the relative one. This one we had seen that this is the absolute refractive index case. Second one is just the reverse of it. So we have to just reciprocate it, and the value we got. Now this question is refractive index of glass with respect to water. This is the purely an example of your relative refractive index. Okay. So, children, just see here the refractive index. This is the for glass. What we can write refractive index of glass with respect to water, Ng by Nw, right? Ng is how much? Ng just now we had seen this one 3 by 2. Okay, it is 3 by 2 divided by Nw is how much? This one, this is 4 by 3. Now cross multiply it, 3 by 2 into 3 by 4. Okay, this becomes 9 by 8. That is what we got here. I hope this is also clear. Refractive index of diamond is the highest. That is 2.42. You have to just remember, refractive index of diamond means we can write just like this. That means we are comparing with air, right? If this means what? The speed of light is 1 by 2.42 times less in diamond than in vacuum. Children, one more thing, let me tell you some of the example over here so that you will be clear. Suppose refractive index, any object, it is for x, it has been given 1.5. Okay, in x means, in suppose this is a glass or water, whatever it has been given. Suppose it is glass. Achha, for your understanding, let me tell you, refractive index of glass is 1.5. What does it mean? It means that if it is simply written G, that means what? It is compared with air or vacuum, isn't it? So what we can say, the refractive index of glass is 1.5 times more than that of the refractive index of air, right? Or alternatively we can say, because refractive index is nothing but we are finding out the speed of light in those mediums, isn't it? So what we can say, if the refractive index is more, that means the velocity or the speed of the light is less, right? इफ हमने जैसे देखा था एक घना जंगल, उसमें हमारा स्पीड कम हो जाता है कंपेयर टू द रेयर वन. सेम थिंग यहाँ अगर 1.5 है ग्लास का, एयर से ज़्यादा है, तो फिर क्या हो रहा है यहाँ पे? तो एयर में ज़्यादा अच्छे से ट्रैवल कर पाएगा देन ग्लास. सो ऑल्टरनेट वे में हम क्या बोल सकते हैं? द स्पीड ऑफ लाइट इन केस ऑफ ग्लास is 1.5 times less than that of the speed of light in air. I hope, and the same thing is been said for diamond. I hope this is clear to you all. With this explanation part is over for refractive index. Now few more questions we will discuss on the same topic, refractive index. So in the next video you will find few more questions based on this. Okay, thank you.